Hello everyone, my name is Priyanka Agarwal and I am a PMRF scholar at Chemical Engineering Department of Indian Institute of Science. And I am conducting these live tutorial sessions for the course on NPTEL Differential Equation for Engineers, which is taken by Professor Srinivasa Manam from IIT Madras. So today we will look at some of the problems related to the second order linear partial differential equations. So let's do a quick revision of what these equations look like so that it will be easier for us to solve the further questions. Okay. Second order linear partial differential equations. So the general form is A double derivative of u with respect to x plus b uxy plus c uyy plus d ux plus e uy plus f u equals to g, where all these a, b, c, d, e, f and g are functions of x and y. So now we can classify these equations into three types, either as hyperbolic, parabolic or elliptic. Now as in quadratic equations, uh, we define the quadratic equations as hyperbolic, parabolic and elliptic. Same goes here. So let's see delta, which we define as b square minus 4ac. Now if this is greater than 0, then the equation is hyperbolic, and if b square minus 4ac is equal to 0, then the equation is parabolic, and if b square minus 4ac is less than equal to 0, then the equation is called elliptic. So all these equations are solved in a different way. That is why we classify these equations. Now let's see a problem where we have to classify the particular one-dimensional damped wave equation. So let us consider this equation, which is 9uxx equals to utt plus 6ut. Now we have to classify this equation from one of these three categories. Okay, so first let's write in the form, the general form. So in general form, if we rewrite it, it becomes 9uxx minus utt minus 6ut equals to 0. The coefficient of uxx is a, a equals to 9, coefficient of uxt, which is 0, and coefficient of utt is -1. Therefore, b square minus 4ac in this case comes out to be 9, which is greater than 0. Hence, this equation is of the hyperbolic type. Now, let's look at another example where we have to classify this particular equation 3uxx plus 3uyy equals to 5uxy plus 9ux plus 17u. Now again, to classify, we will first rewrite it in the general form, which is 3uxx minus 5uxy plus 3uyy, and rest we don't care because they don't govern the behavior, minus 9ux minus 17u equals to 0. Now, if you compare it to the general form, here a equals to 3, b equals to -5, and c is equal to 3. Therefore, b square minus 4ac, what it becomes? 25 minus 4 into 3 into 3, 25 minus 36, which is minus 11, and this is less than 0. So this particular equation is of elliptic type. Now similarly, look at another example where the differential equation is uxx plus 4uyy equals to 4uxy plus 3u. Now to find its to classify this equation, we will again rewrite it in the standard form, which is uxx minus 4uxy plus 4uyy minus 3u equals to 0. So here a equals to 1, b equals to -4, and c is equals to 4. Therefore, b square minus 4ac is equals to 16 minus this is 0. So therefore, this equation is of the parabolic form. Now, let's see another case. So second thing was that we had to do transformation of x and y into other variables to solve the problem. That is, from one second order partial differential equation, we can get two linear ordinary differential equation and we can solve them. Hence, we can solve the second order equation. So transformation as taught in the lectures was from x and y, it was done into the variables, xi and neta, where both xi and neta are functions of x and y. So if any function is written in the form of x and y such that, then it can be written in the form of zeta and xi and neta, where they are also functions of x and y. And f inverse will exist only when the Jacobian is non-zero. So what is the Jacobian matrix in this case? It is the determinant of xi x, xi y, eta x, eta y, and this should not be equal to 0. Now how is transformation done? So if u is a function of x and y, and we have to write it as an equivalent function of xi and eta, then we can use this del u by del x equals to del u by del xi into del xi by del x plus del u by del neta into del neta by del x. And similarly, we can write del u by del y equals to del u by del xi into del xi over del y plus del u over del xi del eta into del eta over del y, and so on. So this is ux, this is uy, and similarly we can write for uxx, uxy, uyy, all in terms of xi and eta. Now the canonical forms were talked about in the course, or we also call these normal form. So basically the given PDE, which is something of the form A uxx plus B uxy plus C uyy, and lower order terms equals to 0. This is then converted, that is transformed into the form A star u xi xi plus B star u xi neta plus C star u neta neta, and the other lower order terms, where A star is A xi x square plus B xi x xi y plus C xi y square, and B star is 2A xi x eta x plus B xi x eta y plus eta x xi y plus 2 zeta y eta y. and C star can be written similar to A star, A eta x square plus B eta x eta y plus C eta y square, right? Now here the Jacobian should not be equal to 0. Okay, now we have to choose A star equals to 0 to fix transformation variables. Zeta and this. So this has already been told in the lecture how to find these. So basically if for b square minus 4ac not equal to 0, we can consider either a star equals to 0, from which we will get zeta as a constant value, and therefore that can be written as differentiation will be d xi equals to 0, then xi x dx plus xi y dy equals to 0, and then dy by dx can be written as minus xi x over xi y, and this equation then is of the form a dy by dx whole square minus b dy by dx plus c equals to 0, and therefore dy by dx can be written as b plus minus under root b square minus 4ac over 2a, right? So now these are two different ODEs. Canonical form for hyperbolic and elliptic is of the form b star u of xi neta plus the lower order terms equals to 0, and for the parabolic it is c star u neta neta plus lower order terms equals to 0. Okay, so we have done the quick revision. Now let's solve some problems. Okay, so separate this equation into an equation of x and an equation of t. Okay, So let u of x comma t equals to capital X and t, and rewrite the equations, given equation in terms of x and t. Okay, so this equation would become, so given equation is t cube u x x plus x cube u t t equals to 0. So this becomes t cube into x double dash into t plus x cube into t double dash x equals to 0. So this is now t cube into t x double dash equals to minus this x cube x into t double dash. Now you divide with x double dash and t double dash on both sides. So what we get is t cube into t over t double dash equals to minus x cube into x over x double dash. So this term is only a function of t and this term is only a function of x. Therefore, both of these terms will be can be written as equal to some constant. So let that constant be equals to minus lambda. So the equation becomes t cube t over t double dash equals to minus lambda, and this then becomes t cube t equals to minus lambda t double dash, and this equation becomes lambda t double dash plus t cube t equals to 0. The other equation will be minus x cube x over x double dash equals to minus lambda, and that becomes minus x cube x equals to minus lambda x double dash, and this becomes lambda x double dash minus x cube x equals to 0. So these are the two equations, and this is what was asked in the question. Now similarly see a question where we have to separate this second order differential equation into two linear ordinary differential equations. Ux plus 2 utx minus 10 utt equals to 0, and we are also given the boundary conditions. U at x equals to 0 and time t is 0, and u at x, u of x at L comma t is 0. So we are given these boundary conditions. Okay. So let's solve in the similar manner, where we first assume that u is function of multiplication of x and t. This is called separation of variables method. And this becomes x prime t plus 2x prime t prime equals to 10x t double prime. Right? Now if we divide this with, so basically u of x will be x prime t and u tx will be x prime t prime, and this becomes x into t double prime. Now let's divide it with x prime t double prime. Now this becomes then t plus 2 t prime over t double prime equals to 10x over x prime. So we can write this equal to some constant because both of these are only functions of t and only functions of x. So the equation becomes t plus 2t prime equals to minus lambda t double dash. This can be then written as lambda t double dash plus 2t prime plus t equals to 0, and the other form is 10x over x prime equals to minus lambda, and this becomes lambda x prime plus 10x equals to 0. So we have these two equations. Now we should also consider the boundary conditions and write them in the form of x and t so that these can be solved. So first boundary condition given to us was u of 0 comma t is 0. So this implies that x of 0 and t at t equals to 0. So this would mean that either this is true or this one is true. Similarly, if you see for the other boundary condition where u of x at L comma t is equals to 0, then x prime L plus t equals to 0. So this also implies either x dash L equals to 0 or t of t equals to 0. Now if you look at these two equations and say, if we said t of t equals to 0, then this would result in a constant 0 solution, but that is not we want. So if we said t of t equals to 0, it would result in constant 0 solution. Therefore, we must write it in the non-trivial form. So we must choose the two non-trivial conditions. Therefore, x of 0 equals to 0 and x dash at L equals to 0. Okay. So let's see another question. which is x square uxx minus 2xy uxy plus y square uyy plus x ux plus y uy equals to 0 for x greater than 0, that is the half plane. Now classify this particular equation. Now you see that this equation is having variable coefficients, but the condition to classify remains the same as it is for the constant coefficients. It is same for the variable coefficients. So in this case, it is already written in the standard form. So A can be written as x square, B is minus 2xy, and C can be written as y square. Now if you do b square minus 4ac, what we will get is 4x square y square minus 4x square y square, which is 0. So this equation is of the parabolic form. Okay. Okay. Now let's see another question. Where u of xx plus 6 uxy plus 9 uyy equals to 0. Now we have to solve this particular question. Now here if you see a is 1, b equals to 6 and c is equals to 9. So b square minus 4ac is equal to 36 minus 36, 0. So this equation is of the parabolic form. Now we know what the canonical form for parabolic equation looks like. So let's go back and see. This is what the parabolic canonical form looks like. C star u neta neta and all the lower order terms are that is equal to 0. Okay, so the canonical form is C star u neta neta plus lower order terms equals to 0, and we know what C star is. A neta x square plus b neta x neta y, right, and plus c neta y square. I think I'm right. Let's see. Okay, so this is the form. Now we need to find this neta, or we can also write in terms of zeta. Okay, so now let's write what dy by dx will be. So dy by dx was b plus minus under root b square minus 4ac over 2a. Now this is 0. Therefore this becomes b over 2a. So dy by dx is 6 over 2, which is 3. So dy can be written as 3 dx. Okay, so we can choose either zeta or neta as a constant on that plane. Like if these are two planes, this corresponds to zeta and this corresponds to neta. So we can choose either here zeta will be some constant and here neta will be some constant. So in this case, let's choose xi equals to this dy minus 3 dx. So this xi becomes y minus 3x as some constant, and let neta equals to y so that the Jacobian is not equal to 0. So if you see Jacobian for xi and neta, what will it be? With for y minus 3x comma y, so this becomes minus 3 0 1 1, and this is minus 3, which is not equal to 0. Okay, so now we have xi as y minus 3x and neta as y. Now let's do the transformation over here. So u of x can be written as del u over del xi into del xi over del x plus del u over del neta into del neta over del x. So what does this ux becomes? This can be written as u xi into del xi by del x, which is minus 3 plus u neta into 0. So ux becomes minus 3 u xi. Now similarly, u of y can be written as del u over del xi into del xi over del y plus del u over del eta into del neta over del y. Okay, so this is u xi and del xi over del, this is 1, this is u neta and this is 1. So uy becomes u xi plus u neta. Okay, now let's find uxx, which is del by del x of ux. This can be written as del ux by del xi into del xi over del x plus del ux over del neta into del neta over del x. What will this become then? Del by del xi of minus 3 u xi into del xi by del x. So we know that xi is y minus 3x and neta is y. So this becomes minus 3 plus this becomes del by del neta of minus 3 u xi into 0. Okay, so what it becomes? Minus 3 into minus 3, this is 9 u xi. So this is uxx. Now what other terms do we have in the equation? U xy and u yy. So let's find those. Now u x y can be written as del by del y of u x, or the other way around also, where we can write it as del by del x of u y. So let's keep this. So this becomes del by del xi of uy into del xi over del y plus del ux over del neta into del neta over del y. So this becomes the same thing, right? Which is minus 3 u xi xi into del xi over del y is 1. Now plus del ux over del eta. This becomes minus 3 u xi neta into del n over del y is 1. So uxy becomes minus 3 u xi xi plus u xi neta. Now let's find uyy, which becomes del by del y of uy. And what is uy? Del by del y of u xi plus u neta, right? So this is what we had. This is one thing, and then we have this. Now let's find this. So this can be written as del by del xi of u xi plus u neta into del xi over del y plus del by del neta of u xi plus u neta into del neta by del y. Okay, so what is this? Let's write it here. Okay, so we know del by del xi of u. Okay, so del by del xi of u xi is u xi xi plus u xi neta into, now del xi over del y is 1 plus this becomes u xi neta plus u neta neta into del neta over del y is again 1. So this becomes u xi xi plus 2u zeta xi plus 2 plus u neta neta. So this is u y y. Now let's see what the original equation was. This. uxx plus 6uxy plus 9uyy. So let's write it down. 6 uxx sorry so uxx plus 6 uxy plus 9 uyy equals to 0. Okay, so what is uxx? Okay, so first let's write uxx, which is 9u xi xi. So 9u xi xi plus 6 times uxy, which is minus 3 times that term. So this becomes minus 18. You can remove the plus sign from here. So minus 18 u xi xi plus u xi eta. U xi xi plus u xi neta. And then this is 9 u xi xi plus 2 u xi neta plus 2 plus u neta neta. And this is equal to 0. So what will this be then? Minus, see this is 9u xi xi and minus 18. So this is then 0 u xi xi. Then this is minus 18 u xi neta and this is plus that. So again 0 u xi neta and then this becomes 9 u neta neta equals to 0. So this implies u neta neta equals to 0. This is the canonical form of the given equation. Okay. Any doubts still here? Okay, well, if not, let's see another question. Um, so the question is, you have to find the canonical form for this equation. Now this is with variable coefficients. So with quick analysis, we can say that A is 1, B is 0 and C is x square. So b square minus 4ac will be minus 4x square. Okay, so it is given that this is elliptic everywhere except on the coordinate axis. X equals to 0. So we have to find the characteristic variable and hence write in the canonical form. Okay. So we now know that delta, that is b square minus 4ac, is equals to minus 4x square. Okay, so for x not equals to 0, this is elliptic. Okay, now let's find the characteristic variables. So dy by dx can be written as b plus minus under root b square minus 4ac over 2a. Here b is 0, so this becomes plus minus under root 4x square minus over 2. So this becomes plus minus iota x, right? Okay. So dy by dx is now iota x, and the other equation is that dy by dx is minus iota x. Now these are the two characteristic equations. Now we have to integrate these characteristic equations and find characteristic variables. So let's integrate first. So this is like dy equals to iota x dx, and this is dy is minus iota x dx. So this becomes y equals to iota x square by 2 plus some constant, and this becomes minus iota x square by 2 plus some other constant. Okay, so where these C1 and C2 are complex constants. Okay, now once we have these, we have to find the we have to do the transformation. So let's write this. This equation becomes y plus iota x square by 2, which is some constant, and y minus iota x square by 2, which is some other constants. Now let's do the transformation. Okay, so for transformation, let's choose alpha as y plus iota x square by 2 and beta as y minus iota x square by 2. Okay, now the real and imaginary part of alpha and beta give the required transformation. So from these, if we take the real part together and the imaginary part together, then we can get the required transformation variables, which are the xi and neta. Required transformation variables xi and neta. So xi can be written as alpha plus beta by 2, which is the real part. Okay, so real part will be this y, and neta can be written as alpha minus beta over 2y, which gives x square by 2. So this is the imaginary part. Now with this zeta equals to y and neta equals to x square by 2, we can reduce the given equation to the canonical form. So let's see what ux is. Ux will be del by del zeta del xi over del x plus del u by del neta into del neta over del x. So this becomes u xi, and del xi over del x is 0 plus u neta del this becomes 2x over 2. So ux is now x times u neta. Similarly, we can do for u y. So that will be del u over del xi into del xi over del y plus del u over del neta into del neta over del y. So this is u xi into 1 plus u neta into 0. So uy becomes u xi. Okay. Now ux becomes del by del x of ux, which is del by del xi of u xi, which is x u neta into del xi over del x, which is 0 plus del by del neta of x u neta into del neta over del x, which is x. So this becomes x square u neta neta. Similarly, u y, it becomes del by del y of u y, which is del by del zeta del xi of u xi into del xi over del y, which is 1 plus del by del neta of u xi into del neta over del y, which is 0. So this becomes u xi xi. And similarly, uxy can be written as del by del x of u y, which is del uy, which is del this over del xi into del xi over del x, which is 0 plus del by del neta of u xi into del neta by del x, which is x. So this becomes x times u xi neta. Now let's go back to the given equation, which is uxx plus x square uyy. So this is uxx plus x square uyy equals to 0. Now if you substitute, this becomes x square u neta neta plus x square u xi xi equals to 0. So this equation becomes u xi xi plus u neta neta equals to 0. And this is what is called the canonical form. Okay, yeah. So we will stop today's session over here, and thank you for attending this session. See you next week. Bye.